Hello, hi everyone. So here in this workflow, we are going to evaluate a typical classification problem. So I think this is the same problem that you're familiar with, activity 2. So I'm talking about activity 2. So here we are looking at data from a bank. I think we were discussing in the class. It's the data from the bank. So bank is actually trying to train a machine learning model. It is a decision tree based machine learning model to kind of understand the relation between two things. One is there are certain um, input variables are about what do you say, the KYC details, typically what you submit during a typical bank loan application. So we have seen this example earlier. I'll just bring it back for you to remember. So there are the outcome variable here is credit rating 0 and 1, and age, income, credit card, education, and car loans are your input variables. So we are trying to train machine learning model. So your training data.csv is there in the folder. We will just go here, and it's already identified, so it's there in your folder data session 5 training data.csv. So once you do it, you kind of run it and see what is there. So you take a quick look at what data is there. About 6 columns are there. The first one is your output, the output variable or the target variable. So 2464, right? Every row represents a customer. And now what am I going to do here is just do some manipulation. Okay, there is nothing. So basically, this is just manipulating the data to have it in a format that the decision tree wants. So the first one is even if this table manipulator is not there, it will work. But just let me show you how it is. So I want to change. So I have just done this thing. So this is credit rating was in strings. So I've just converted into a bit vector. You can choose here string to bit vector, string to HTML, all that you can choose. So bit vector means the target variable is basically a 0 and 1. Bit vector means basically 1 and 0, right? Binary. So we have done that. So you can just run it, and in the next here there is a rule engine. So basically the decision tree learner algorithm wants the target variable to be in a categorical format. So in order to write it in a better way, we have said, see, credit rating equal to 1, then it is known as credit worthy, or you could have written good also. um, so this is more better to understand. And true is all other cases. Default outcome is risky. So there are only two cases. So credit worthy, and the default outcome becomes risky, right? Good credit, bad credit. So then what you are doing here is using the rule engine. You are creating a target variable, which is of a string type or categorical type, and yeah, it's string type as is shown here, right? So you basically 0 1 is converted into credit worthy and risky. So that's what you get if you check here. There is one more added column. Basically, this you have created a target variable from the credit rating variable. That's what you've done, right? Now you don't need this credit rating and target together. So I've just filtered out. So here I'm filtering out the credit rating, the first variable. So I've just removed it. 0 1. It's no longer required because you have the redundant variable, which is the target, known as target. So I'll just say okay and I'll run it. So now comes the training part. So I think you're familiar with this. We can only see for assessing the model, we need to um, train the model using some part of it, and also test the model, because for testing you need to have the true class or the true value of target variables, right? So this is, you don't have any other data, 2464. Now you have to train the model maybe using 70% of the data, and test whether the predictions of the model is correct or not, because for these 2464 customers, we know whether they have defaulted, whether they are good credit or bad credit earlier, right? So then that's what partitioning node is for. There you can do a kind of sampling, stratified sampling, or any other forms of sampling. So we have just kept it as 70 percentage uh, um, goes to the upper arm, and 30 percentage goes to the other arm. So if you want the result to be the same, you should check this box. Okay, so you just run it. So what happens is data is actually getting partitioned. 70% it goes upstream, and this is another. There are two output ports, right? So then you apply a very classical decision tree learner. Is you've been learning this earlier also. You've seen the example. So here you have to specify certain things. Let's see what is there. Okay. So target variable, maybe you have to specify that. This is target variable. Then the second question is about which ratio you are using. What is the splitting criteria? So we are using a C5, which is the best decision tree. So we are using information gain ratio. So gain ratio in short. So pruning method. Pruning is a way to kind of reduce the misclassification error, reduce the size of the what do you say the tree. There are two pruning methods. One is reduced. There is default. This is on error pruning, and there is an MDL method. So we will just keep this default reduced error pruning on. So what happens is the model doesn't become. There is a problem of overfitting, right? Model capturing the noise in the data that can be avoided, right? So now then there are certain criteria, right? Minimum number of records per node. So the splitting should stop when it reaches a minimum number of records per node, right? That's mentioned here. You can increase this, and then for this is always checked in because you for continuous variables you need to split it at average point. So we keep it like that, and this is about the speed of the processing, so nothing to do with any of the model. It doesn't affect the model output, right? So then root split is if you want to start instead of the splitting criteria, which is information gain here, if you want to force the root split column with start with maybe age or something, you can do that, but we just don't recommend this. And if the splitting criteria is a nominal variable, it can split into maybe three or more classes, right? So otherwise, if you check this, it will always result in a binary split. So here I think all the numbers are coded, even though some of them are categorical in nature. If you have coded it in a way that is continuous, so I think that's where you can change those things using the table manipulator. You can make it categorical so that it kind of understands it as a categorical, right? So we will just leave it like that. If you want to make it the tree to split always in a binary mode into two arms, then you can check that, right? So now we just run this. Yeah, so it is already learned. It was pretty quick, right? So there is a decision tree view attached. So otherwise also you can get the decision tree view from the original node. This is just another way to represent it, to display it. So you can go on. So here if you check at this node, if you check, there are 6 cases. All of them are risky, so it stops there, right? The others are continuing because there are, it's, yeah, it here also it kind of stops. So now you can take that decision extract that rule through that particular arm, right? The whole branch through which it goes. So, so I'm not explaining how to interpret the decision tree here, which you have already done. So now um, come back to the decision. There is another decision predictor, right? So here you are, whatever model you have learned, this particular branch You're transferring that learning to decision tree predictor and applying it to 30% of the data which is coming from the model. So you have to make sure that you check the, what do you say, this box, because it's for, if you want to use ROC display curve, there you have to actually need some data. So always remember to check this box if you want to display it using ROC curve. Okay, so we will run it, and these two scorers are actually the same. Okay, these are two different ones in terms of how they display, but actually the functionality is the same. Scorer is classifying into, this is a confusion matrix. It tells you what is the accuracy, overall accuracy, 76%, and these are classified correctly: true positive, true negative. These are false, what do you say, type 1 error and type 2 error, so false positives and false negatives. So it compares the what is actual and what is predicted, um, and how good. So you've studied all specificity, sensitivity, and all the different ways to measure it, right? So you can get it from here. I think it displays accuracy here, and the other things you can always kind of, I think we will check here what happens here. Here also it is the same, but it kind of gives you more detail in terms of what is sensitivity and specificity and all that. It gives, so accordingly you can apply, right? A little more better view maybe for taking out the results. This is better. Now there is the last one, how to visually display it. It's the ROC curve. So let's just open this. So it's what are you displaying? Target column, and you have to specify the positive class value and actually select the same, the last one. So these two variables are actually created by the previous node. Probability of target is equal to risky and probability of target is equal to credit worthy. So we'll just see what happens here. So this is the curve that you're getting. So the area under the curve is 803, which is above the threshold of 0.75, which says it's a relatively good predictor, a good classifier. So that's how you kind of evaluate the model, right? So you can go back to the lessons on how to evaluate, what are the accuracy measures, what are the best practices, and all that. But this is how you execute the workflow related to classification, evaluation of the classifier.